9 o'clock. Yes. So the name of the chapter is Introduction to the Polymer Chemistry, marks 3 with option 4. And it is the chapter number 15. Already I have given the weightage of all chapters in the first lecture. And I am very happy to inform you all, this chapter is written by me for HSC board. Yes, anyone started the videos? Please put up your videos. Yes. Close your videos. These are the some questions asked in previous board exams. Already I have sent this PPT to you. So you can go through these questions after finishing the chapter. We have to write the answers of these questions. So these are in this slide, we can see here, there are some examples of some polymers we are using in our day-to-day life. In this slide or in this picture, you can see out of these many substances or many instruments we are using in our day-to-day life, all these substances we put in one folder, and that folder is called as plastic. But it is not plastic. I want to give information about this plastic. Plastic is one of the polymer. Polythene is one of the polymer. So as we proceed, we will understand it is not plastic. It is made up with polymer. It is made up with backlight. So if you don't know the knowledge of these polymers, you can put all them in plastic. But I want to give one information. This is not plastic. This is all these are polymers. So in this slide also you can see many day-to-day life things are there. All these are made up with polymers. This is a synthetic rubber. This is also the one of the polymer we can prepare in the laboratory. In this first diagram, you can see many plastic, polythene articles are there, mugs and trays. In this diagram also you can see the buckets. In this diagram, you can see the sprays. It is prepared by using low density polythenes. So I want to give information about the polymers in this chapter. So remember one thing, though the introduction part is deleted in other chapters, in this chapter introduction part is not deleted. One question will be asked for introduction. Remember, purposefully the introduction is kept for this chapter. But if you see the deleted and non-evaluative syllabus of this year, we can see in many chapters introduction part is deleted, but for this chapter introduction is not deleted because 1 mark question will be there in the form of MCQs or in the forms of one answer question, short answer questions will be there. So I will introduce what is meant by polymers first. The polymers, these are the very large molecules, macromolecules. Macro means these are very large molecules having the high molecular weight. Because of the macro, it is having high molecular weight. The weight will be increased because it is very long chains are there. Then these are prepared with small repeating units are called as monomers. See, the polymer is a very large molecule and it is prepared by a small repeating unit. It's called as monomers. These monomers are repeated. Then polymer, it is a Greek word. Poly means many parts, many, and meros means parts. So many parts they combine together and we will get the giant molecule. And this giant molecule is called as polymer, remember. So the monomers are simple molecules. These are very small molecules, and these monomers having very specific capacity. See, the monomers having capacity to form chemical bonds to other monomers, both the sides. From both the sides, these monomers can combine and a large molecule will be formed. In the next slide, I will show what is monomer and how the polymers are formed. See, these are some examples of polymers in our day-to-day life. I have given here proteins, you know proteins, then DNA, deoxyribonucleic acid, nails, hairs, PVC pipes, plastic, raincoat, then tires, carpets, and this polythene. Now, what is meant by polymerization? Polymerization means it is a method of preparation of polymers. See, in the introduction part, 1 mark question will be asked for board exam, remember. So purposefully, I have not deleted this part. I have kept this part because I want to ask 1 mark question on it. Remember, all the students, please note this part. So polymerization means what? It is nothing but the process of synthesizing or preparation of these polymers is called as polymerization. So polymerization is process of preparation of polymers. Then see how the polymers are prepared. One example I have shown in the first slide purposefully. See, ethene you know very well. And this is a n number of ethenes. N means very large. N number of ethyns means we can't mention here. It may be 100, 200, 300, 400, 500, 1000, 2000, 10,000. N means number of ethene molecules are there. So these n number of ethene molecules after the polymerization process. See on the arrow, polymerization means it is a method of preparation of polymerization. See, this is a repeating units are formed. These are the repeating units. In the repeating units, you can see clearly this a double bond is not there. This double bond is broken, and from the both sides, this monomer can grow. See, this side, right hand side. In the right hand side, the line is there. So the bond is there. What is the meaning of this bond? This repeating unit can be added to right hand side also, and this repeating unit can be added to the left hand side also. And we get here, see the very large macromolecule. It is having n number of repeating units, and this molecule is called as polythene polymer. So purposefully I have shown this example in the first slide because all the polymers are prepared by using this method. Okay, then next one, see how these monomers and polymerization takes place. These are the monomers. See, these are the very small repeating units, and in the polymerization process, after the polymerization, monomers are combined together and they are having capacity to form the bonds to the both sides, and this is a large molecule is formed. Such molecules are called as polymers. So polymers are prepared by using monomers. Monomers are very small simple units. So the question will be asked for board exam for 1 mark. What is mean by monomer? What is mean by polymer? What is polymerization? Such examples will be asked for the board exam. Now, the classification of polymers, there are on the basis of 6 types of classifications are there. See, 1, 2, 3, 4, 5, 6. 6 types of classification of polymers is there. First one is classification based on source or origin. Means from where this polymer is obtained, and or origin means from where the polymer is obtained, from plants or animals, or it is prepared in laboratory. So depending upon the source, these polymers are classified. Then second one is classification based on structure. How the structure of the polymer is there, linear structure or branch structure or cross-link structure. Depending upon the structure, these polymers are classified. We will see all these classification in detail, but in the first side, you should know how these polymers are classified. Then third one is based on the mode of polymerization. Mode of polymerization means how these are prepared, by using addition method or by using condensation method. Then fourth one is classification based on intermolecular forces. What type of forces are present in the polymers, whether these are the van der Waals forces or hydrogen bonds or covalent bonds. Depending upon the intermolecular forces, these polymers are also classified. Then next one, number 5, classification based on type of different monomers. Different types of monomers means if the same monomers are used, these are the homopolymers and heteropolymers. So depending upon the monomers, also the polymers are classified. And last one is classification based on biodegradability. You know this word biodegradability means if the polymers are biodegradable, these are kept in biodegradability, and the polymers which are non-biodegradable, these are kept in non-biodegradability. So one by one we will see in the detail. This chart will be not asked for exam. Note this thing. This is only for information, for understanding how the polymers are. No any question will be asked on this chart. So forget about this chart. Now I am directly coming to the classification based on source. We can see here three pictures I have shown purposefully, but after this explanation, you can understand why these pictures are shown. First one, classification based on source. Source means from where these polymers are prepared, from which source. First one, natural polymers, it is the, as the name itself suggests, natural polymers are obtained from nature. These polymers are obtained from plants or animals. So depending upon these are also called as plant polymers and also animal polymers. If the polymers prepared from plants, these are called as plant polymers, and the polymers prepared from animals, these are also called as animal polymers. So, for examples are given here: cellulose, then jute is there, then silk, wool, protein, starch, then natural rubber, linen, etc. If you see these diagrams carefully, this is jute. This bag is made up of jute, and jute is obtained from plants. Silk is obtained from animal, silkworm. Then wool is also obtained from the animals. So it is a silk, wool, these are the animal polymers. Jute is a plant polymer, cellulose is a plant polymer, then protein, starch, these are also called as animal polymers, and proteins can be obtained from plants and animals also. Then natural rubber, this is obtained from the plants. Then linen, it is also obtained from plants. So all these are the examples of natural polymers. Then I am coming to the next class, semi-synthetic polymers. Semi-synthetic polymers, these are actually the natural polymers. Natural polymers, only the chemical treatment is given to the natural polymers, and the prepared polymers are called as semi-synthetic polymers. So you can write in your own words, if it is asked for exam, you can use this textbook language also, bookish language also, and you can write in your own words also. So semi-synthetic means actually these are the natural polymers, but some chemical treatment is there. These are modified polymers, and which things are modified I will explain. Some chemical treatment is given to the natural polymers, and semi-synthetic polymers are prepared. So chemical treatment is given for modifying their appearance, then for increasing their tensile strength, for increasing the strength, and luster. So all these properties are modified only, and the prepared polymer is called as semi-synthetic polymer. Semi means these are the half. Semi means half, and synthetic means prepared in laboratory. So 50% they are natural, and 50% they are their appearance is changed due to the some chemical treatment. And the examples are, see, cellulose, all the cellulose derivatives such as cellulose acetate, then cellulose acetate rayon, then viscous rayon, cuprammonium silk, cuprammonium rayon. All these examples are the semi-synthetic polymers. Only the chemical treatment is given to the natural polymers. Then see, this is the example of semi-synthetic polymers also. This diagram is shown. In the this picture is shown. And the third one is synthetic polymers. Synthetic means these are purely 100% these are prepared in laboratory, 100% these are man-made. In the laboratory these are prepared, so that's why these are called as synthetic polymers. Remember, synthetic means it is 100% prepared in laboratory. First one is nylon, terylene, polythene. These are the some examples. of the synthetic polymers. You can see in this figure also synthetic rubber. This is a football, or this is a basketball. 100% it is prepared by the laboratory. And this is nylon ropes. These are prepared in the laboratory. Man-made polymers, polythene bags. These are also prepared in the laboratory. They do not appear from the natural source. So these are the some examples of synthetic polymers. I think you understand the classification based on source. So next part is classification based on structure of the polymers. See, in this diagram, or in this slide, we can clearly see here there are some straight lines and there are some branching is there. So these linear polymers or straight chain polymers, these are in linear structure. That's why I have purposefully shown this diagram to you. So you can easily understand, if the polymers are in straight chain or in the linear, they are joined together in linear arrangement. Such type of polymers are called as linear or straight chain polymers. When the monomers molecules are joined together in linear arrangement, the resultant polymer is a straight chain polymer, and it is obtained from bifunctional monomers or alkenes. Means many times the alkenes are the linear polymers. For example, PVC. PVC, it is a polyvinyl chloride. Polyvinyl chloride. It is prepared from the vinyl chloride. You know the vinyl group. What is vinyl group? I have explained in detail in chapter number 12. That is alcohols. What is meant by vinyl alcohols? So this is prepared from vinyl chloride. We will see in the next examples. High density polythene. High density polythene. This is also the example of linear or straight chain polymers. These are in they having the straight chain structure like this. Then branch polymers. As the name itself suggests, these polymers are having some branches. Means one line, one main chain is there and other chains are branch. See, the example of this polymer is low density polythene. High density polythene is a linear polymer and a low density polythene is a branch polymer. Purposefully, I have given these examples because this is asked for board exam. Which of the following is a linear polymer and which of the following is branch polymer? So don't make confusion. There are two types of polythenes. One is high density. It is having density is high, and one is low density polythene. Another example is polypropylene. See here in this example, I have given the propylene here. Propylene and propene is same. This is the propene, N types of propene polymerization. This is a repeating unit, a monomer, and this is a polypropylene. See, the branching is there. As the branching is there, CH3, these are in branching, and this is a CH2. This monomer can be repeated, and we get the polypropylene is a branch polymer. Then next one, network or cross-link polymers. As the name suggests, it is a cross-linkings are there. See, this is a main chain, see in the picture. That's why purposefully I have taken these pictures. See, cross-linking is there. See, there is a one cross-linking, another cross-linking is there. So, the linking of the chain polymers by strong covalent bonds. This linking is done with strong covalent bonds. Due to this, these polymers look like network structure. So that's why these polymers are called as cross-link structure or network-like polymers. Examples are important: bakelite or melamine. These are the examples of cross-link polymers. Means these are prepared with cross-linking is there. This cross-linking is with strong covalent bonds. Remember. Then the classification based on mode of polymerization process. How these polymers are prepared. There are three modes of polymerization process. First one is addition polymerization. It is also called as a chain growth polymerization. Then condensation polymerization. It is also called as straight growth polymerization. I want to clarify one thing. In bracket, it is written chain growth polymerization, because in addition polymerization, chain will be chain growth polymerization means chain will grow across the double bond. In this addition polymerization, the polymer chain will grow across the double bond. And in case of condensation polymers, what is happening? The chain of the polymer, it is growth stepwise. First step, then second step, like this. And third one is ring opening polymerization. So in detail, we will see one by one what is meant by addition polymerization. Addition polymerization, these are also called as chain growth polymerization. As just I have told you, in addition polymerization, chain will grow across the double bond. So in detail, I will explain here. Addition polymerization is a process of formation of polymers by addition of monomers. It is a simple addition of monomers. You can form the polymers without loss of any small molecules, remember. In this, no any elimination of molecule takes place. But in case of condensation polymers, see here, as the name condensation indicates, water molecule will be removed or methyl alcohol molecule will be removed. But in case of addition polymerization, remember, no any molecule will be removed without loss of any small molecules. These addition polymerizations are prepared. Then second thing is, repeating unit of an addition polymer has the same elemental composition as that of the original polymer. Means the meaning of this sentence is, repeating unit of addition polymer has the same elemental composition. The composition of the monomer do not changes in this addition polymerization. Then next one, the compounds containing double bond undergo addition polymerization. Already I have explained this addition polymerization takes place in case of alkenes having the double bonds. Then it is also referred as the vinyl polymerization. Vinyl polymerization means vinyl group should be present there. Since majority of the monomers, these are from the vinyl category, for example, vinyl chloride, then vinyl cyanide. I will give example, vinyl chloride from this monomer, polyvinyl chloride, PVC pipes are prepared. And by using this vinyl cyanide, polyacrylonitrile or polyacrylocyanide, these polymers are prepared. In the next example, in the next slide, I will explain these examples how these PVC and polyacrylonitriles are prepared. Then one of the famous addition polymer is polythene. Formation of polythene, and it is prepared by using ethene, is well-known example of addition polymerization. Then some other examples I have given. Arlon, it is also called as polyacrylonitrile pan. There are three different names for this Arlon. Arlon, then polyacrylonitrile, polyacrylonitrile. If the short form is prepared, it becomes pan. PAN, that is polyacrylonitrile. Then Teflon, then PVC pipes and these polythenes. These are the some examples of addition polymerization. For the examination, board examination, for 2 marks, the question will be asked, write a note on addition polymerization. So in this question, we have to write what is meant by addition polymerization and give the 2 examples. So this example I have given here, this is a vinyl cyanide, see. This vinyl group means double bond, this is CH2 double bond CH. And this group may be changed. Instead of this cyanide, if OH is there, it will be vinyl alcohol. Instead of this cyanide, if the chlorine is attached here, it becomes vinyl chloride. If bromine is attached here, it will be vinyl bromide. If iodine is attached here, it will be vinyl iodide. So vinyl group is CH2 double bond CH, and this is a branch. This can be changed. Depending upon this group, the name of the vinyl group will be decided. So vinyl cyanide, after polymerization, this is a repeating unit C, double bond is removed from the both sides. This monomer can grow. So this is repeating unit, and this is in bracket. I always we have to remember, for the writing the polymer, bracket is written. What is the meaning of this bracket? Means this repeating unit, this is repeated from this side, and this is repeated from this side, right hand side and left hand side, and the number is n. N number means we cannot define it, maybe 100, 200, 300, 400, thousands, and many things. N means no any specific number is there. So n number. So we have to write the reaction. If it is asked for board exam, you have to write in this way. vinyl cyanide. Then polymerization, we have to write one arrow here. Then we have to show the repeating unit, and in bracket we have to write this. And N is important here. If you forgot to write this N, you will lose your half mark, remember. So this N is very important, remember. Don't forget to write this N, because without N, we can't treat as polymer. If N is not written, it becomes monomer. See, the next example is written here. This is the monomer is tetrafluoroethylene. Tetra means 4, and fluoro means 4 fluorines are there, CH2, CH2. So hydrogens are removed. Instead of these hydrogens, fluorines are kept. So this is called as tetrafluoroethylene. Tetrafluoroethylene. If ethene is there, ethene forms polythene, and if tetrafluoroethylene is there, they forms polytetrafluoroethylene. It is also called as Teflon. See, Teflon having the another name is polytetrafluoroethene, PTFE, polytetrafluoroethene. It is also called as Teflon. Teflon, it is used for the coatings of utensils. Then a free radical mechanism is included, but for the board exam, this mechanism will not be asked, remember. But you should know how the mechanism takes place, how the mechanism of addition polymerization takes place. First step is formation of free radical. Then second step is chain initiation. First radical, free radical is formed. Then the chain initiation means chain will be started. Then the third step will chain propagation. Chain will grow. And last step is chain termination. Chain termination can be brought about the first thing by not supplying of monomer. We have to stop the monomer, then chain will stop. Then second one, by addition of impurities like oxygen. And third one is by coupling of the two chains of the polymer. So addition polymerizations are prepared by using this mechanism. I will give one example, but we have to remember these are the 4 steps. 1, 2, 3, 4. First step is formation of free radical. You know, free radical is chargeless species. It is only having the electrons. Then chain initiation, chain will be started. Chain propagation, chain will grow. Chain termination means we have to stop the reaction. We can stop the reaction by using these 3 methods. We have to stop the monomer. Supply of the monomers should be stopped. Then second one, by addition of impurities like oxygen. If the oxygen is added, then chain will stop. And third one, by coupling of 2 chains of polymers. Next one, I have given one example here, how the free radicals are formed. We will take one example here. All the 4 steps are explained in this reaction. This will be not asked for board exam. Remember, first already I told you this is only for your understanding purpose, how the chain, sorry, how the polymers are prepared. Which polymers? Addition polymers are prepared by using this free radical mechanism. 10 minutes are remaining. So I will explain very fast. This is a benzoyl peroxide. See, this is a benzoyl peroxide, and how the free radicals are formed in 11th standard also I have explained. This bond will be broken by using fish hook arrows. Such arrows are called as fish hook. They look like a fish. These are the heads of the fish, and these are also called as head of the fish. So such type of arrows are called as fish hook arrows. This is a homolysis. This bond will be broken, and we get here 2 free radicals. See here, dot we can see clearly here, dot 2,6,C6H5CO, and this is O dot. So 2 free radicals are prepared first. This is phenyl, and the CO2 is removed. Again this bond will be broken. Again, see, we can see clearly this bond is broken, symmetrically breaking. It is called as homolysis, and 2 phenyl radicals are prepared and 2 CO2 molecules are removed. So in the first step, we can see clearly the free radicals, how the free radicals are formed. Free radicals are formed by using this process. This process is called as homolysis. Then the second step, already I explained, is the chain initiation step. Now this benzoyl peroxide, it is a catalyst First free radical is prepared. Now this is taken. See, this is a ethene. This is ethene molecule. CH2 double bond CH2. Now this free radical is prepared. Again in the second step, this double bond will be broken. This double bond will be broken and the free radical is prepared here. See, CH2, CH2 and this C6H5, this C6H5 free radical. And if this bond is broken, again we will get the CH2 dot radicals and we will get this C6H5 CH2 CH2 radical. This is radical. Again another CH2 will be added. Again third molecule will be added. Fourth molecule will be added. Fifth molecule will be added. So chain will grow. Means many number of CH2 molecules will be added and the chain will grow. We can see this structure. See this structure. C6H5 in bracket CH2 is written n times. So n times and CH2 both the sides the chain will grow. So this is n number of CH2 molecules can be added. So this is the chain propagating step. First one is a free radical is prepared. Second one is chain is started. Then chain will grow and last step is we have to stop the reaction. Now we can stop the reaction by three methods. First one is we have to stop the supply of, see the previous slide, we have to stop the supply of monomer, we have to add impurities like oxygen and we have to do the coupling. So in this method, coupling method is used here. See, this is the first chain, this is second chain, they will couple each other and the reaction will stop. So this is very large molecule will be prepared. See, it is not very large, it is very easy to understand. This is one chain, this is another chain, only these are joined together. But don't get confused. This is not very large structure. See, CH2 is written only and both the sides only phenyl radicals are written. So we can write easily C6H5, CH2 n times and C6H5. This is a chain coupling reaction and we'll stop the reaction at this stage. This is chain termination step. So I'm not wasting my time because this is not asked for board exam, but this is asked for board exam. Condensation polymers, also called as a step growth polymerization, because in this polymer will grow stepwise, first step, second step, like this. So in this, as the name condensation is suggested here, small molecules are removed here. So which molecules are removed, I will explain here. See, molecules like water, methyl alcohol, ammonia. See, either water, then CH3OH or ammonia, hydrochloric acid, these molecules are removed. In case of, so such type of polymers are called as condensation polymerization, in which the process of formation of polymers from polyfunctional monomers. See, this is a very important thing here. Polyfunctional monomers means monomers having the not same functional group. Different monomers are used here. If the same monomers are used, we get the addition polymers, but the main condition of this condensation polymer is polyfunctional. Poly means many functional groups are there. See, polyfunctional monomers are there. We'll see one example. On the basis of example, we can easily understand what is meant by condensation polymerization. Then the second thing is, in this type of polymerization, chain will grow in a series. Chain will grow in a series and stepwise. So therefore it is called as step growth polymerization. And in case of addition polymerization, the addition polymerization takes place across the, see this slide carefully. Once again I am repeating this slide. In case of addition polymerization, chain will grow across the double bond. In case of condensation polymer, chain will grow stepwise. So again I am coming back to this slide. This slide, say, in this polymer will grow stepwise. For example, polyamide. See, polyamides means 100% amide functional group will be there. All the nylons are included in this. So polyamide, the word itself indicates amide functional group will be there. Then polyesters. So in case of polyesters, ester functional group 100% it will be there. Then pteryline, it is also the part of esters. Then novolac, bakelite, melamine, these are the different condensation polymers. I will explain one by one. Then next part of this classification is a ring opening polymerization. As the name indicates, a ring will be opened in this ring opening polymerization. Uh, See, one example I have given there. Cyclic compounds like lactams. This is one of the lactam. Cyclic ethers, lactones, etc. These are polymerized by ring opening polymerization. This is a very famous example. Nylon 6, at least 15 times this is asked for board exam. So this is very, very important question. Make a mark there in your notebook also and in your textbook also. Write 10 times. This is today's homework for you. Write this classification and preparation of nylon 6. Then also we have to write the reactions, how the PVC and Teflons are prepared, Arlons are prepared. So this is today's homework for you. We have to write this reaction nylon 6 10 times, because many times it is asked for board exam how nylon 6 is prepared. So nylon 6 is prepared. This is the lactam, and the name of the lactam is epsilon caprolactam. The name of the lactam is polymerization of epsilon. E stands for epsilon caprolactam, preparation of nylon 6. Now see, this is in case of nylon 6, 1, 2, 3, 4, 5. 5 methyl groups are there and the carbons are 6. Say, this is CH2, 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 CH2. 1, 2, 3, 4, 5 CH2 groups are there. Then one carbonyl group is there, and this is CONH. This is amide functional group. CONH. CONH is amide functional group. So it is a total 7-membered ring. In last year, how the question is asked on this, in case of caprolactam, dot dot methylene molecules are present. So it is a quite confusing question. 1, 2, 3, 4, 5. 5 CH2 groups are there, but total carbons are 6. And the question was quite confusing. The question was like this: in case of in case of nylon 6, how many CH2 groups are present? Such type of questions were asked for board exam. So carefully we have to write. 5 CH2 groups are there and there are total number of carbons are 6. That's why it is called as nylon 6, because it contains 6 carbons. This CO is also included as a carbon. This is 5 carbons and this is 6 carbons. The ring will be broken from this NH and CO. So this ring will be opened. This CO NH, this bond will be broken. If it is heated at the temperature 533 and 543 in presence of water, the bond between CO and NH will be broken, and this is a polymer is formed. This is a ring opening polymerization, CO dash. What is the meaning of this dash? Means polymer, this repeating unit will be, again, it will be from this side also, right hand side also, and left hand side also. See, right hand side also it will be repeated, and left hand side it will be repeated. That's why these bonds are shown, and N indicates this will be repeated. This entire unit will be repeated.